good morning and good afternoon. Today, our group gonna present about movie recommendation system. But before we start, this is a member in our group, and I'm sharing about table of the content in our project. The first one is introduction. Two is detail of application. The third one is implementation. The fourth one is mathematical concept. And the last one is conclusion. First of all, I will tell a little bit about a movie recommendation system. A movie recommendation system is a type of algorithm design to suggesting a film user is likely to enjoy based on the rating they given to other movie or the behavior of similar user. Let's move to the next section. In this part, I will tell that movie have the power to enhance our life, but selecting the perfect one can be hard, right? To make it easier, we build a recommendation system using a collaborative filtering and linear algebra like matrix factorization to predict what user might like and suggest a movie. So in this project show you how math is used to create personalized and data-driven solution in technology.
Next part, I will walk you through the details of building movie recommendation system, a tool designed to suggest movies based on user preferences and viewing history. This system leverages linear algebra to handle and analyze large datasets, finding the pattern that predict user interest in movies they haven't watched yet. And we divided to 6 steps, that is, data overview, exploratory data analysis, data preprocessing, item recommendations with k-nearest neighbors, collaborative filtering, and the last one, dimensionality reduction with matrix factorization. First, we start with data overview using the movie lens dataset, which contains 100,000 ratings for 9,000 movies and 600 users. We focus on the key columns such as user IDs, movie IDs, ratings, titles, and genres. These datasets serve as the backbone of our recommendation system. Next, in exploratory data analysis, we explore the data structure and distribution of our data, and we can gain the insight like on average, each user rated 167 movies, and each movie received about 11 ratings. And we also visualize the rating distribution to spot trends, and we identify popular movies like L'America, which stand out for its high ratings despite limited user interactions. For data preprocessing was the next critical step. Here we clean and organize the dataset, transforming it into user item matrix. This matrix is crucial for collaborative filtering, which row represent user, column representing movies, and the cell containing ratings. This structure is the foundation for the further modeling.
Item recommendations use the k-nearest neighbor algorithm to find movies similar to a given movie based on user ratings. The system relies on a user item matrix where rows present users and columns present movies. By comparing user engagement vectors, it determines movie similarities and generates tailored recommendations. Collaborative filtering focuses on user item interaction in the utility matrix. However, it faces the cold start problem, where new users or items with insufficient interaction data are excluded. Content-based filtering can help mitigate this issue by leveraging users and item features to generate recommendations. To improve usability, the fuzzy-wuzzy library matches user input to the closest movie title. Even when typos are present, a function like Movie Finder automates this process, ensuring accurate and seamless user interaction while enhancing the recommendation systems. Dimensionality reducting two matrix factorization decomposes the user item matrix into two smaller matrices, uncoding hidden patterns in user-movie interactions. This process reduces dimensionality, improves handling of sparse datasets, and enhances recommendation accuracy. The k-nearest neighbor algorithm is then applied to the reduced movie factor matrix, leveraging 20 latent components such as movie genres to deliver precise, diverse recommendations.
About implementation, step 1, matrix factorization using SVD is using singular value decomposition. We break down the rating matrix into three matrices, is U, sigma, and VT. And step 2 is reconstruct the matrix. First is construct the reduced matrix. Suppose we choose k equal to, meaning we keep only the top two singular values. And the second is use the formulas to get an approximate ratings matrix R. Step 3 is making recommendations. First is identify top recommendations that use the reconstruct matrix R to identify the top movies recommendation for each user. About novel theory, we have 4 users and 5 movies with the following user movie rating matrix are. Ratings are on a scale from 1 to 5 and 0 indicates an unwatched movie. This deconstructed movie matrix is used to make recommendations for each user based on their predicted rating.
In our project, we use linear algebra to prevent fundamental tools for building effective movie recommendation system. Here are the concepts. The first one, metric and vector. The metric represents the user preferences for movie, and the vector represents individual user or movie in a high-dimensional space. You can see from the right, row represents the user, column represents the movie, and each entry rating is 1 to 5, and a 0 represents the unwatched movie. Let's go to the second one, metric factorization. This process is to decompose a large user item metric into a small metric, capturing latent factors that explain user preferences and movie characteristics. So down here is a formula that we calculate the missing volume in R based on the product. Next is singular volume decompositions. In short, we can call SVD. From the metric factorization that reduce the dimensionalities and identify the pattern in the data. So this process is to help to predict missing rating and uncover hidden relationship between user and movie. So the picture down here is showing that the step to decompose the data. And the last one, vector space and dimensionality reduction. The vector can be represent the user and movie in a high dimensional space, and the dimensionality reduction technique like SVD is to help to simplify the data while preserving initial information. So all of this is the math concept that we use to prevent the accurate and personalized recommendations. That's it for math concept.
To conclude, our project demonstrates how linear algebra and data science come together to create a practical and impactful solution in the form of a movie recommendation system by leveraging collaborative filtering, dimensionality reduction, and user item interactions. We were able to predict the preferences and offer personalized suggestions. This project not only highlight the importance of mathematics in technology, but also shows how these tools can enhance everyday experience, such as choosing a movie to watch. And that's all for our project. Thank you everyone for your attention.